And R naught is called Fermi's constant. I told nucleus is a highly dense region, is directly proportional to its mass number. What portion of it is defined as atomic mass unit? There is only one proton and one neutron inside it. Hello students, let us in this session continue our discussion on the chapter Nuclei. In my yesterday's class, we had a bird's eye view to the introduction of the chapter, where we understood what actually was the nucleus, how nucleus is represented, and we also learned something about the isobars, isotopes, and isotones. Continuing my discussion further, in my today's class, we will understand the general characteristics, or what we call as general features of the atomic nucleus. We try to understand what is nuclear size. We try to understand what is nuclear mass and give a concrete description to the density of the nucleus. Now, the first characteristic that we study is called as nuclear size, the size of the nucleus. Now, experiments have shown that the volume of a nucleus is directly proportional to the number of nucleons present in it. That is, the volume of the nucleus is directly proportional to its mass number. See, very beautiful thought. The volume of the nucleus is always directly proportional to the number of nucleons present in it, number of protons and neutrons present in it. That is what we call as the mass number. Nodi, ಯಾವುದೇ ಒಂದು ಮನೆಯನ್ನ ಕಟ್ಟಬೇಕಾದ್ರೆ ಅದ್ರ ಸೈಜ್, ಆ ಮನೆಯಲ್ಲಿ ಎಷ್ಟು ಫ್ಯಾಮಿಲಿ ಮೆಂಬರ್ಸ್ ಇರ್ತಾರೆ ಅವರನ್ನ ಅಕಾಮಡೇಟ್ ಮಾಡೋಷ್ಟು ಸಾಕಾಗಬೇಕು. Here we told nucleus is spherical in shape. Nucleus has the shape of a sphere. If you consider hydrogen, there is only one proton and one neutron inside it. So its volume is very small. Whereas you consider uranium-235, there are 235 nucleons. The house uranium-235 requires is of bigger size. Why? More number of members, more number of nucleons. So, very clearly we say the volume of a nucleus, the space inside the nucleus, is directly proportional to the number of nucleons inside it. Number of protons and neutrons inside it, the so-called mass number. Now all of us know volume of a sphere is given by V equals 4 by 3 pi r cube, where r is the radius of the sphere. My simple geometry says volume of any sphere is equal to 4 divided by 3 pi r cube. Recall that expression where r is the radius of the sphere. Since we have treated a nuclei to be a sphere of radius r, we say 4 by 3 pi r cube is directly proportional to A, where A is the mass number, or r cube is proportional to A. 4 by 3 and pi, they are scalars. So r cube is proportional to A, or r is proportional to A to the power 1 by 3. So radius of a nucleus is proportional to A to the power 1 by 3, where A is the mass number of that nucleus. Now, eliminating that proportionality, we introduce a very important constant called R naught. R naught is a very, very important constant, and it is called Fermi's constant. Enrico Fermi is considered to be the father of nuclear physics, and R naught is called Fermi's constant. One Fermi mathematically is 10 power minus 15 meters. It is a measuring unit in nuclear physics. One Fermi is equal to 10 power minus 15 meters, and the value of R naught is 1.3 Fermis, or 1.3 into 10 power minus 15 meters. But for me, this inference is important. The radius of any nucleus is directly proportional to the cube root of its mass number. For 1 mark, this is always asked. The so-called size of the nucleus, what I talk as the radius of the nucleus, is directly proportional to the cube root of its mass number. How does the radius of a nucleus depend on its mass number? It is directly proportional to the cube root of its mass number. So, always remember the volume of any nucleus is directly proportional to the number of nucleons inside it, and the radius of a nucleus is directly proportional to the cube root of its mass number. R0 is called Fermi's constant. Value of R0 1.3 Fermi, and 1 Fermi is 10 power minus 15 meter. The next is what we call as nuclear mass. Imagine a situation where I go to the market and say, I ask a vegetable vendor, sir, 1 kg atoms idre kotbidi sir, ಅಥವಾ 1 kg nuclei, ಚೆನ್ನಾಗಿರೋ nuclei na ಆರಿಸ್ಕೊಡಿ sir. The person says, boss, you have to be somewhere in space, not here. ಯಾಕೆ ಟೊಮ್ಯಾಟೋನ ಆರಿಸ್ಕೊಡ್ತೀರಾ, ಆನಿಯನ್ ಆರಿಸ್ಕೊಡ್ತೀರಾ? Why not atoms or nuclei? My dear students, the mass of atoms or nuclei is measured indirectly in terms of a unit called atomic mass unit. So the unit used to measure the mass of atoms and molecules is AMU, which is atomic mass unit. Now, what is atomic mass unit? Atomic mass unit is defined as 1/12 the mass of carbon 12 atom. It is 1/12 the mass of carbon 12 atom. Andre, if I consider a carbon 12 atom, what portion of it is defined as atomic mass unit? Not half of carbon 12, not 1/4 of the mass of carbon 12. It is 1/12 of the mass. Slightly absurd to understand. Yenidu 1/12 mass of carbon 12. ಏನೋ ಒಂದು ಕಾರ್ಬನ್ 12 ಆಟಮ್ ತಗೊಳ್ಳೋದಂತೆ, ಅದರಲ್ಲಿ 1/12 ಕನ್ಸಿಡರ್ ಮಾಡೋದಂತೆ, ಆ 1/12 ಮಾಸ್ ಡಿಫೈನ್ ಮಾಡೋದು AMU. 1/12 the mass of carbon 12 atom. ಇವೆಲ್ಲ ಬಿಟ್ಟು ಈಸಿಯಾಗಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೋಬೇಕಾದ್ರೆ 12 grams of carbon 12 is what is called 1 AMU. ಅಷ್ಟೇ, ರಾಕೆಟ್ ಸೈನ್ಸ್ ಏನಿಲ್ಲ ಇದರಲ್ಲಿ. 12 grams of carbon 12 is what we call 1 atomic mass unit. Therefore, 12 grams of carbon 12 contains how many atoms? It has to contain Avogadro number of atoms. Any mass of a given substance should contain Avogadro number of atoms. So 12 grams of carbon 12 contains 6.022 into 10 power 23 atoms. ಇಲ್ಲಿ ಗ್ರಾಮ್ಸ್ ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ ಕೆಜಿ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೊಳ್ತೀನಿ. ಸೊ 12 into 10 power minus 3 kg of carbon 12 again contains Avogadro number of atoms. So 1 AMU, what I call as X, is 1 by 12th the mass of carbon 12 atom. Simplify this. 1 AMU turns out to be 1.66 into 10 power minus 27 kgs. Simple definition. 1 by 12th into the actual mass of carbon 12, which is 1.66 into 10 power minus 27 kgs. So, observe students, 1 atomic mass unit in terms of kg is 1.66 into 10 power minus 27. And mass spectroscope is the device which is used to measure the mass of a nucleus. Now coming to nuclear density, very initially I told the entire mass of an atom is situated in a small dense region at the center called nucleus. I told nucleus is a highly dense region. Now nuclear density is calculated as nuclear mass by nuclear volume. This calculation is what I want you all to perform by assignment. Nuclear volume you know, nuclear mass you know. This is very important for me. On calculation, we observe that the density of the nucleus is 1.81 into 10 power 17 kg per meter cube. My dear students, just concentrate on this power. 10 power 17, by no imagination in this world, 10 power 17 is a small number. If you go to the density of water, 1000, which is 10 power 3, can it be comparable? No. That is why we say density of the nucleus is very, very high, in the order of 10 power 17. And hence we say nucleus is in a highly dense state. And please do remember, nuclear density is independent of the mass number. For any nucleus, the density is in the order of 10 power 17 kg per meter cube. Therefore, in my today's class, we understood three important characteristics of the nucleus, being nuclear size, nuclear mass, and nuclear density. The next session, I'll have written back with few other interesting concepts like mass defect, binding energy, nuclear forces. Until then, have a look at the previous sessions. Thank you.